First topic is about motion under gravity. So motion under gravity, this motion can be without air resistance. It can be with air resistance. So when the objects are falling without air resistance, even though they have different masses, if we drop the two objects from the same height, so what we will observe, if they hit the ground, both will hit the ground at the same time. So why the two objects will hit the ground at the same time without air resistance? Because they have constant acceleration, and this constant acceleration, which is also known as acceleration due to gravity, that's the exact value is 9.8 meter per second square. So if we sketch a graph for falling objects without air resistance, if there is no air resistance acting, every second the speed will change by 9.8. You have to take now acceleration due to gravity as 9.8. So on x-axis, if we have a time, on y-axis, if we have velocity, so 1, so as this object is dropped, initial velocity, the starting velocity of the object is 0, because initially it is at rest. So in the beginning, initially the object is at rest, the initial velocity is 0. After 1 second, what will be the velocity of A? Because they have the same constant acceleration, which is 9.8. So after 1 second, the speed, originally it is 0, changes to 9.8. So speed will be 9.8 for A and 9.8 for B, meter per second. Then after this 2 seconds, it will be 19.6 for A and for B as well, same 19.6. Why? Because they have the same acceleration due to gravity, 9.8. And after 3 seconds, it will be 29.4 for A and same 29.4 meter per second for B. When we calculate the acceleration for first second, from first to second, or from second to third second, we will find that this constant change in speed is there with respect to time. So they have the constant acceleration. So when we sketch this result, after 1 second it is 9.8, after 2 seconds it is 19.6, after 3 seconds it will be 29.4. So when we join them, it will be a straight line with a constant slope, and the gradient or the slope of this line represent acceleration, which will come out 9.8 meter per second square. Is it clear? Acceleration, motion under the gravity, the acceleration of a falling object without air resistance, if there is no air resistance acting on the object. Practically, how we can find this experiment to find acceleration due to gravity? So if we want to find the acceleration due to gravity, there are different methods which we can use. We can use a light gate because we have to find the time interval. So using a light gate, we can determine the time interval, or using the light gate, we can also determine the instantaneous speed. How we can use a light gate to find the acceleration of a falling object? So we will take a cylindrical tube and we are dropping this object. The reason why we are taking a cylindrical tube, so that the air resistance, the surrounding air, will not affect the motion. And at the bottom, we place the two light gates. The distance through which this object is falling, that distance is known, the height. We will measure the length of the object. As this object fall to the bottom, it will cut the light gate with the light beam basically. Light gates are there operated by the light sensing switches. So what happen, as the light is passing through from one light gate to the detector, but as this object will move through or in between the light gate, it will cut the light, and moment it will cut the light, the timer will start and we will know how long it will take to pass through these light gates. So using this, length is known and the time we can determine using a light gate. So we can find the speed at this point. So speed is equals to distance over time, so length of object divided by time, we will get the final speed. So we know the speed, and we know for the height from which we are dropping this, and we have this equation of the motion. What is the equation of the motion? 2as is equals to v square minus u square. Initially, because whenever object is dropped, initial velocity is 0, so it will be 2. Acceleration is due to gravity. So acceleration is due to gravity. H is a height from which we are dropping. Initial velocity is 0. The final velocity we can identify from the light gate. So it will become 2gh is equals to v square. Or I can say v square is equals to 2gh. If I compare with the equation of straight line, y is equals to mx plus c, but because the y-intercept is 0 here, so on y-axis, if I sketch v square, so on y-axis, we have v square. On x-axis, we have the distance from which we drop. So we can vary that distance because so that we'll have different values for height and speed. So when we sketch a graph, the graph will be a straight line. So the graph will be a straight line which is passing through origin, and our gradient, the gradient will be equal to 2g, or gravity is equals to gradient divided by 2. We will get the gravity. So this is a way, experimental way, to find the acceleration due to gravity for falling object using a light gate. Is it clear how to find the acceleration due to gravity using the light gate? The experiment, the whole working, I will send the file so you can go through that. The procedure is important. Is it clear? Any doubt in this part? Acceleration due to gravity for a falling object without air resistance using a light gate. We can also use electromagnet method, acceleration due to gravity, using electromagnet. So what we can do in this electromagnet, we have an electromagnet and a sphere, a ball is attached to this electromagnet. And at the bottom, we have a tap switch. And we have a two-way switch. Which is initially connected to first position A. And we have a timer. So First, when it is connected to first position, the current is passing through, electromagnet is magnetized, the steel ball, a magnetic material, which will remain in contact. Then we will measure the distance between the electromagnet and the tap switch. Now, the moment we change the position, we move this two-way switch to position B. So what happened? Now B is in connection. So electromagnet will be demagnetized. The moment it will demagnetize, the ball will start to fall. We know what height the ball will fall. And the moment the ball will hit this tap switch, so when this ball will hit the tap switch will open, because it will lose the connection, move down, so the tap switch will open. So we'll know the time, how much time the ball is taking, because when we move to position B, the timer start. When the ball hit the tap switch will open, the timer will stop. So we will know how much time it will take to fall to this height, and we will change this height and repeat the experiment and get different time. Now, which equation we will use? We have the equation S is equals to ut plus half at square. Initial velocity is 0 because for falling object. S is the height through which it is falling. U is the initial velocity 0. So this whole factor will be 0. So this will be 1 by 2. Acceleration is due to gravity and time t square. So if I compare with equation of straight line, y is equals to mx plus c. On y-axis, if I plot height, on x-axis, if I plot time square, the y-intercept is 0, so time square. Then what will be the gradient in this graph? The gradient will be g by 2, or I can say 2 multiplied by gradient will be equal to g. So in this case, the acceleration due to gravity will be twice of the gradient. So we can find the gradient y2 minus y1 over x2 minus x1, and using this gradient, we can work out the acceleration due to gravity for falling object by using electromagnet. Then we can also use stopwatch or camera. If we are using a camera, so we will the number, because for every camera there are frames per second, which is constant. So frame per second multiplied by number of the frames, we can work using that ratio, we can work out the time and distance. By using a same equation, we can find acceleration due to gravity. So this experiment can be done in different manners. Light gate and electromagnet is the one, or you can also use a normal timer stopwatch. But using a stopwatch, there are errors like reaction time. It will be difficult to stop this. So it will be difficult to stop in a short time. So reaction time is there. Then we have Newton laws. What are Newton laws of motion? According to first law of motion, if an object is at rest, it will remain at rest, or if an object is moving, it will continue to move until unbalanced force act on it. So that's the Newton first law. If an object is at rest, it will remain at rest. If an object is moving, it will continue to move until there is unbalanced force act on the object. Or in short, we can say if the resultant force is zero, the object will not change the state. So example, there's an object which is originally at rest. Initially it was at rest, and two forces are acting in opposite direction. Say example, a 3 Newton is towards right and 3 Newton is towards left. So the resultant on this object is zero. If the resultant force is zero, this object will remain in its own state, and we also call this as inertia. So inertia is a property of an object to resist the change in state. Same way, if the object was moving and now the forces are balanced. Like example, if you take example of the car, when you accelerate the car, like you press the accelerator, the car changes the speed. In that case, the forces are not balanced. But once you are moving with a constant speed, it means the forces are balanced now. So car is now a moving object, and if the forces become balanced for moving object, so the force which is driving the car and the force which is opposing the motion. So if 2000 Newton is driving force and 2000 Newton is a frictional force. So resultant force is zero. So when the resultant force is zero for a moving object, so it will remain in motion. This object will continue its motion. And why it continues its motion? Because of a property which we call inertia. So inertia is a property of an object to resist the change in state. And inertia is proportional to mass. Greater mass, it means higher inertia. That's why, like example, if a car is moving and a truck is moving with the same speed, so it will be difficult to stop the truck because it's having greater mass, or we can also say it is having a greater inertia. Is it clear? The Newton first law. When object is at rest, it will remain at rest. If an object is moving, continue to move until unbalanced force act on the object. Then Newton second law. So according to second law, if resultant force act on the object, it will produce acceleration, means it will produce a change in the speed. It can be increase in speed or it can be decrease in speed, but it will produce acceleration. And according to Newton law, the resultant force, so according to Newton law, resultant force is equals to ma, or we can say resultant force is directly proportional to acceleration if mass is kept constant. So if we sketch a graph between the resultant force, this is a submission sign, it means the resultant force and acceleration. So it will be a straight line which will start through region, and the slope of this line represent the mass of an object. So resultant force is equals to ma, or resultant force is proportional to A. So how you can use this? An object experience, say object was moving toward, this was the original direction of the motion. A force of 10 Newton and force of 2 Newton are in opposite direction. So what will be the resultant force? So the resultant force, it will be 10 minus 2, which is equals to 8 Newton. And if we need acceleration, so what we will substitute to get an acceleration, resultant force is equals to mass multiplied by acceleration. Resultant force is 8, the mass is 5, acceleration we don't know. So it will, acceleration will be 8 divided by 5, which is equals to 1.6 meter per second square. So we here, whenever we substitute, we always substitute resultant force. So the greater the resultant force, greater the acceleration when mass is kept constant. If the direction of the resultant force is same, same as direction of the motion, the object will accelerate. And if direction of the resultant force is opposite to direction of the motion, the object will decelerate or slow down. Then the third law, according to the third law of motion, action and reaction forces are equal, or forces always act in pairs. Or action and reaction force are equal but opposite in direction. So action and reaction forces are equal but opposite in direction, or forces act in pair. Means, example, an object is on the ground. So if object is on the ground, there is a downward force, the gravitational pull is there, and because of that downward force, so there is a downward force by the object onto the surface. So object will apply a force on the surface. So if object is applying a force of 3 Newton, then according to Newton third law, as the forces act in pair, the ground will also apply a same force but in opposite direction. So a resultant of another force is there of 3 Newton. So downward force is a downward force by object on the ground, and there is an upward force by the surface or the ground onto the object. And what are the characteristic of Newton pair forces? So characteristic of Newton pair forces, they are always acting in their same type of forces. Same type of forces, as we know, there are four basic fundamental forces. Strong nuclear, strong nuclear force exists between the particles which are within the nucleus or subatomic particles such as quarks. Weak nuclear, gravitational, and electromagnetic. These are the types of the force. Means whenever there is a force exists between the particle, it can be one of them, it can be all of them, uh, like three of them, two of them, or but it should be categorized as same. So if there is a downward force, contact forces are normally electromagnetic forces. So when the objects are in contact, so the as an applying force on each other, so forces refers to electromagnetic force. So when objects are in contact, or the charges are there, or the magnets are there, so they have electromagnetic force. So what does it means? The characteristic of a pair force, it means they are of same type. Means if there is this is a electromagnetic force downward, so the upward force is also electromagnetic. They are same size or same magnitude. If one is 3 Newton, the other is also 3 Newton. Opposite direction, acting in the same line. Means acting on the same line means if one force like downward is there, the other upward force is also starting with the same point, or where we can join them with one line. That's the meaning of acting in the same line. If I draw like this, it means it is not acting in the same line. Acting on two different objects, acting in same time as well, and opposite direction. So whenever the forces are acting, they are always acting in pairs. So example, this is Earth and you're standing on the surface of the Earth. So if you're standing on the surface of the Earth, if we say identify the Newton pair forces. So what are the Newton pair forces? First thing, Earth is pulling us by a force, and according to Newton pair force, we are also pulling the Earth with the same force but in opposite direction and acting in the same line. So the Newton pair force, first one, the gravitational force, of Earth on the body or the object, and the second one is a gravitational force of body or object on Earth. So if I say the weight of the object is 600 Newton, so weight of the object is 600 Newton, how much force we are by which, because the weight is refers to the force by which Earth is pulling the object towards the center. So if Earth is applying a force of 600 Newton, The object is also pulling the earth with the same force but in opposite direction. Both are the gravitational forces. Then there is also another Newton pair force. So these two are the gravitational forces. But then when we compare the surface, like this part, the surface only, so objects are also like earth surface is in contact with the object, and there is a downward force. The gravitational force is there downward, which is 600 Newton. But that downward force is now the electrostatic force, electromagnetic force, because that's due to the in contact. Whenever in contact are there, so we call that as electrostatic or electromagnetic force. So 600 Newton downward. What happened? The surface will also apply a force of 600 Newton upward. So the downward force by the object is equals to upward force by the surface. But how we explain that, for example, if you want to jump on the surface of the earth, how you are able to jump? So it's a simple concept, the same gravitational, like this is a earth and you're standing on the earth. Your weight example is 600 Newton. So a 600 Newton force is downward, and earth is, you are also pulling the earth with the same 600 Newton. As you are standing on the ground, so there's a weight 600 Newton, and there is an upward force of 600 Newton by the ground. So there is no resultant force. But what happens if we want to jump? What we try to do, we try to push the ground. So basically, when we try to push the ground, so 600 is already our weight acting down, and we try to push the ground. So what we do, we change the total downward force, 600 already because of the weight, and 100 example we applied. So the total downward force which we applied, the total downward force is 700 Newton. So if total downward is 700 Newton, what will be the total upward force? The total upward force from the ground will also be 700 Newton. So as the total upward force is 700, now when you check, the gravitational pull is 600 and the ground is applying a force of 700. So which direction you have a resultant force? You have a resultant force in upward direction, which is 100 Newton. That's why you will change the state or you will accelerate upward. Is it clear? How we explain we can jump on by pushing the ground. So basically, when we push the ground, we apply more downward force. As a result, there is greater upward force, which that upward force is more than the gravitational pull of the earth, so which create a resultant force, and we accelerate upward. Is it clear? The Newton first, second, and third law. Any doubt in this? I'll share another link and discuss some questions related to Newton law.